Good morning. Today we are going to discuss about electrode potential, understanding the driving force of redox reactions. Before going to the topic, we discuss the basic introduction about electrochemistry. Electrochemistry means it is a branch of science which deals with the relationship between electric current and chemical reactions. Generally, chemical reactions can be classified into two categories. One is oxidation reactions and one is redox reactions. Both oxidation and reduction reactions takes place simultaneously. That reaction is known as redox reactions. Then the conductors. Conductors means the materials which conduct the current to pass through it. That material is known as the conductors. Example for the conductors. Good morning. Today we are going to discuss about electrode potential, understanding the driving force of redox reactions. Before going to the topic, we discuss the introduction about electrochemistry. Electrochemistry means it is a branch of science which deals with the relationship between chemical reactions and current. Generally, chemical reactions can be classified into two categories. One is anode reaction and one is cathode reaction. That means oxidation reaction, and one is redox. Good morning. Today we are going to discuss about electrode potential, understanding the driving force of redox reactions. Before going to the topic, we discuss introduction about electrochemistry. Electrochemistry means it is a relationship between the chemical reactions and current. Chemical reactions can be classified into two categories. One is oxidation reaction and one is redox reactions. In some cases, both the oxidation and reduction reactions takes place simultaneously. That reaction is known as redox reactions. Then conductors. Conductors means a substance or materials that allows the current to pass through it. It is called conductors. Example, all metals and graphite. Then non-conductors, a material which do not allow the current to pass through it. For example, plastic. This is an example for non-conductors. Then types of conductors. Conductors can be classified into two categories. One is metallic conductors, another one is electrolytic conductors. Metallic conductors means it is a solid substances which conduct the current due to the movement of electrons from one place to another place. That is known as metallic conductors. The metallic conductors, the conductance increases with decrease of the pressure of your gases. The next, electrolytic conductors. Electrolytic conductors means it is a substances which conduct the current by the movement of ions or movement of electrons in solutions. Then electrolytes. Electrolytes means it is a completely ionized substances which conduct the current from one place to another place due to the movement of ions. Electrolytes can be classified into three categories. One is strong electrolyte, another one is weak electrolyte, another one is non-electrolyte. Strong electrolyte means it is a substance which ionized completely at all dilutions. Then weak electrolyte means it is partially ionized in a dilute solutions. Example, ammonium hydroxide. Acetic acid is an example. Non-electrolyte means these electrolytes do not ionize at any dilution. Example, glucose and sucrose. The next one is fundamental components of electrochemical cell. Current, electrode, anode, cathode, then salt bridge. Current means flow of electrons through a wire at any conductors. Electrode means it is a metallic rod which conduct the current. Anode means oxidation occurs. Cathode means reduction occurs. Both anode and cathode connected through a wire to form a cell. So automatically it creates current. The next one is electrode potential. Electrode potential. What is meant by electrode potential? Generally, metal consists of metal ions and valence electrons. When a metal is placed in a solution of its own salt, oxidation or reductions occurs due to the movement of ions and electrons. The voltage developed at the boundary between an electrode and its surroundings electrolyte solution. Then electron tendency measures the natural tendency of chemical species to gain electrons or lose electrons. That means reduction and oxidation. Then surface phenomena originates from complex charge transfer process and ion adsorption occurring at the electrode surface. So in electrochemistry, electrode potential is very important, very important one to identify the spontaneity of the reactions. Thank you.